Okay, and here we are at figuring out how to name our hydrocarbons. So far you've heard me talk about the names in terms of using them, but it may sound like I'm speaking a different language to you at the moment, so we'll try and decode this, and this will be the last topic that I'm going to cover in the videos before the holidays. So we'll see how you go with that, remembering that you should have practiced drawing the structures of these as well. Okay, so we know that isomers have the same molecular formula, but they go together in a different way. So we need a way to tell the difference between them. How do I know if my C6H14 is going to be a straight chain hexane or a different isomer of it? And essentially it comes down to the name. Okay, the way that we name these is essentially like a set of coordinates that tells us where the carbons all go together. So for straight chain hydrocarbons, those ones that just go together all in a chain, okay, like this, the first part of the name refers to the number of carbon atoms, and hopefully you figured that already. Okay, so for 1 it's meth, for 2 eth, 3 prop, 4 bute, and then after 4 it is pent, hex, hept, oct, non, and dec. So after 4, all the prefixes are just the same as what you use for maths. Okay, it's the first 4 that are a little bit harder to remember, and there's a way to actually remember it, and that's what this guy is here. Okay, the way to remember the first 4 is the mnemonic: monkeys eat peeled bananas. Okay, so MEPB, so we get meth, eth, prop, and bute. Okay, so monkeys eat peeled bananas give us the first 4, and then it's pent, hex, hept, oct, non, and dec. Okay, so the first part of the name tells us how many carbons it is. The second part of a name tells us which functional group or homologous series it belongs to. Okay, so hopefully you've realized that over the time we've looked at the alkanes homologous series, all the compounds that we've looked at have ended in ANE, and that's because they're part of the alkanes homologous series. Okay, so ethane here, eth and ANE, tells me that it has 2 carbon atoms and that it ends in ane, so it belongs to the alkanes homologous series, so it will have the formula CnH2n+2, which means it will have single bonds only. So I need to put it together. All those carbons that are given in my formula, I need to put together by single bonds on their own. These are some of the other functional groups we'll come to meet later. So ENE means it's an alkene. ANOL, so anol, it means it's an alcohol. Anoic acid means it's a carboxylic acid, and anoate means it's an ester. You may have heard some of these before. We've heard ethanoic acid, okay, which was our vinegar, which was CH3COOH, and you'll see that eth means 2, and there's 2 carbons in my molecule, and anoic acid actually is this COOH group here, a carboxylic acid. So the names actually give us a lot of information. Okay, so you need to remember monkeys eat peeled bananas, and then pent, hex, hept, oct, non, and dec for our number of carbons, and then the ending tells us the family it belongs to. Okay, so that was a quick summary. So essentially this is the details. The name of the hydrocarbon ends in an ANE. All the carbon-to-carbon bonds are single covalent bonds. If it ends in ENE, then the carbon-to-carbon bonds, there is a double bond. Okay, molecules that have more than one double bond are called dienes if there's 2, or trienes if there's 3. Okay, and then we have INE, which is alkynes, okay, and that means that there's a triple bond in there, so something like this, okay, would be an alkyne. This is ethyne. Okay, whereas ethene would have a double bond in it, C double bond C. This would be ethene. Okay, and then ethane, okay, would be single bonds only, so eth is 2, and then fill every other position out with hydrogen so that each carbon has 4 bonds. Okay, so when we reach more than 4 carbons, we found out that we had isomers, and then isomers mean that we need to name things a little bit different. In order to name isomers, we need to number each carbon in the chain and then name it according to what sits hanging off that chain. So let's have a look here. In order for us to number the chain, we need to find the longest unbranched carbon chain. Okay, and then we number the carbons from the end that gives the smallest number to the carbons that have branching groups. So let's have a look here. This one here, it's the same structure, and there's 2 possible ways that we can name it. We can go 1, 2, 3, 4, 5, 6 this way, even though it goes around a corner. This is a contiguous chain. Or we can name it 1, 2, 3, 4, 5 this way. Now let's look at our rules. It says longest unbranched carbon chain, and then we name it from the end that gives the smallest number to our branching group. In this case, this is a branching group, this is a branching group, okay? So if we have a look, longest unbranched chain must be this one here. Okay, so if we have a look at that one, because this one is only 5, this is our longest unbranched chain here, but we said it will give the smallest numbers to the branching groups, 1, 2, 3, 4. If we actually number from this end, 1, 2, 3, 4, 5, 6, you will see that this one is actually off a carbon with a lower number. So we would actually number from this end being 1, okay? And this molecule would actually be called 3-methyl hexane, 3-methyl hexane, okay? Okay, so as you saw with me doing in the slide just before, when we name branched isomers, we need to consider the size of the branch, and if we give them the same prefix as we do for the length of the chain. Okay, so essentially branches are the same as an alkane molecule but less one hydrogen. So if we look at this one here, it's like CH4 and we've lost a hydrogen, so we get a CH3. Here it's like a C2, so a CH2, CH3, it's like we've got 2 CH3s and we've lost a hydrogen. Okay, so because we've lost the hydrogen because essentially this is going into the chain of the hydrocarbon here. So if it's hanging off a chain, it gets this YL ending. Okay, so we call this methyl if it's a CH3 group, ethyl if it's a CH2CH3 group. You will not see ethyl groups on anything less, so we won't see them on anything less than C7. Okay, so don't try and go naming things with ethyl groups on anything less than C7. Okay, so we saw before. So if I do this one here, okay, we can see it doesn't matter which way I number it from because this is in the middle, so it'll be the same position no matter which end I number from. Okay, this is 5, so my carbon chain will be pent. It's all single bonds, so it'll be ane, but we've got this guy hanging off here, so he will be 3-methyl pentane. Okay, hopefully that's making a little bit of sense. If we look at butane, okay, these are the 2 isomers we saw before. If we have a look here, longest carbon chain 1, 2, 3, 4. In the case of this one, the carbon chain is 1, 2, 3. Okay, there is a branch, a methyl branch on carbon 2. So when we put this together, it becomes 2-methyl prop because it's 3 carbons, and ane because it's all single bonds. It's part of the alkane family. Okay, that is a really quick and easy rundown on the first parts of naming. I want you to have a look at the worked example on 9.1.1 and have a go at these key questions. If you feel pretty confident with this, feel free to read on with the rest of the chapter and go through these PowerPoints. But for now, I'm going to leave it there as being the most that we're going to get through before the break. And I will pick up when we come back to school. So have a great Easter. Please email me if you've got any questions, and I'll see you when we get back to school.